I received 2 Sandoz desk clocks today. They look identical but have completely different movements in them. They both had untouched, pristine dials with glowing radium 226 paint on the numbers. The owner sent them to an individual to remove and replace the radium with a non-toxic, non-radioactive, photoluminescent material. Sadly, both dials came back butchered. Both dials are not only dirty, soiled, and scratched, but as you can see, the replacement photoluminescent material has not been applied smoothly. This one is a 6-joule silver-plated movement. Balance wheel is gummed up. Movement is small compared to the case, so there's a decorative beauty spacing ring installed right here. The second one also shows some poor workmanship on the dial. It's scratched, photoluminescent material isn't applied smoothly, and the black paint used to touch up the scratches is a bit messy. Dials are serviceable, but have been greatly devalued if ever compared to an untouched one. This one is a 15-joule silver-plated movement, adjusted in 3 positions. Balance wheel swings freely in this one. Putting them side to side, you can see the movements are completely different models. Owner has decided to get the 15-joule movement working, so I'll inspect and see what it needs. I see the hands are hitting each other. Mainspring isn't winding. Maybe it's broke. Not much power left in the mainspring, but I'll let what small amount of power there is down. Remove the hands. Loosen the detent screw so the stem and crown can be removed. Three case screws. Inside of case shows several past repair people left their marks. A nice original Sandoz case. 2 dial screws. Some black grease residue on the back side of this dial. Some scratches. This large circular wear mark is from the hour wheel dial washer. This wear mark is from the minute wheel. Here's where the black grease on the dial came from. Dial washer, hour wheel, cannon pinion. The movement is dented here from a past repair person. Remove the balance wheel so it doesn't get damaged. I see the balance pivots are all caked with old dried oil. I'll remove the mainspring barrel and see what's going on with it. Barrel cap to barrel fit up isn't as snug as I like to see them. The barrel almost looks out around. The Swiss tongue end is broke loose from the mainspring. Center wheel, third wheel, fourth wheel, fifth wheel, escape wheel, pallet fork, This cap jewel is completely dry. Mainspring arbor is full of old dried oil. Here's the break in the mainspring. Some of these Swiss tongues are made by folding the mainspring over on its ends. This one has a separate tongue riveted to the mainspring. Best to install a new mainspring. It'll have a better chance of keeping good time. No standard mainspring can be found for this movement, so I'll need to measure and find a matching mainspring by size. When this movement was made, these mainspring gauges would have been used to size a new mainspring. This gauge was made in France. They are a go-no-go gauge. The mainspring is too wide for the 4mm slot, so we'll look for another one. This gauge was made in Switzerland. The mainspring fits the 32 and the 41 slot. It's unmarked, but the 41 refers to 41mm, and the 32 means the Denison scale. This one is Swiss made. Scale is unmarked. Mainspring fits the 30 mark snugly. It's probably the Denison scale. This one is made in the USA and is marked for the Denison scale. It shows 32 on the scale. This small one is unmarked. Shows a loose fit on the 30, so it's probably the Denison scale. This one is made in the USA and is marked for the Denison scale. Snug fit in the 30 slot. For the thickness, the spring is slipped in this slot. I don't use these because they aren't the best for accuracy. They were produced by many different manufacturers at a time when not much attention was focused on certifying tools like these. They are at best a close estimate of what is needed. To be accurate, a dependable micrometer should be used. This one shows slightly over 4.03 millimeters, so it could be rounded up to 4.04 millimeters. These electronic veneer calipers are good, but then the last number is either rounded up or down. This old mechanical veneer caliper actually shows slightly over 4 millimeters, which is quite accurate. The silver plating on these is tarnished. I'll use a little cream of tartar to clean the tarnish. I avoid silver polishes because they can have abrasives in them, and abrasives will remove the thin layer of silver. Where the silver finish is damaged, I use a silvering salt to restore the silver finish. You can see the brass take on the silver in just a few seconds. Looks nice now. The barrel really turned out good. Here's the products I used. The number 1 is a silver salt, and the number 2 is cream of tartar. It's what I use to remove the tarnish, same as can be found in the grocery stores. The movement is clean, time to get it back together. I was able to find a new mainspring, but no sizes available with the Swiss tongue end on them. I'll need to attach a tongue end on the new mainspring. This old tongue is in good shape and is already fitted to the barrel, so I'll use it. Here's the new mainspring. You can see it has a hole end on the mainspring. I'll clamp the tongue to remove the old piece of mainspring. Grind the rivet down to help get the old piece of mainspring off. Nice, the old piece of mainspring popped off easily. I put a center punch in the middle of the rivet so I can drill it out. This high-speed drill bit isn't going to do it. I'll use a carbide bit. Much better. Now with the rivet out, I can locate it on the new mainspring and drill a locating hole in the mainspring. It needs to mount to the outside surface of the spring. To help complete the drilling process, I'll modify this piece of steel into a backup and pushing tool. Nice clean hole. Now to deburr and chamfer the edges of the holes. Measuring the drill bit will give the diameter of the rivet needed. I'll use some blued steel for the rivet. Need a piece slightly larger to allow for the rivet head. Rivet needs to be slightly longer. Diameter is getting real close. The rivet fits nice and snug. I counterbored the end hollow so it will curl over nicely. I used a staking tool and the rivet is complete, ready for service. Now to trim the excess end of the mainspring. File and smooth any sharp edges, then send it to the cleaning machine. Looks good. Time to run it through the cleaning machine. Installed, you can see how the beveled edge on the tongue fits up to the locking surface of the barrel. The barrel looks nice now that the bare brass has been silvered. Oil the mainspring arbor. One of the pallet fork jewels is loose and needs attention. The shellac isn't sticking to it. Looks like someone attempted to modify it and didn't heat the shellac up enough for it to flow. To reset the jewel, a pallet warming tool is used. This one is missing the clamp lever that fits on the round dowel. Heat is applied to the dark ears. This one has several rivets holding it together and a dovetail type of joint here for added strength. Pallet fork is placed here and heat is applied to the brass plate. This warmer has several holes drilled in it, so it can also be used to blue screws. This is a combination warming tool. Its jaws are spring-loaded, used to set roller and pallet stones, holding jewels, holding objects like hands for broaching, and for annealing small arbors. Heat is applied to this end. I'll use this one. It has a nice clamp attachment to hold the pallet. I won't need to add any shellac. There's plenty of it already on there. Here's the type of shellac used to cement jewels. It takes just a small amount of one of these pieces. To heat the shellac, an alcohol burner comes in handy. Just a little heat and the shellac will flow and cement the jewel in place again. Now to see how it runs for the first time in years. Well, it started right up. That's a good sign the pallet stones are adjusted correctly. Adjust the hairspring stud a little. An exceptionally nice running 15 joule Sandoz desk clock.